And just start recording this. Okay, just as a reminder, this is our last class for the term. Our final exam is going to be on Tuesday, December 14th. That's this coming Tuesday. The final exam is on Blackboard, just like the midterm was. It will be available starting at 9:30 in the morning. It must be completed by 3 p.m. Once you start the exam, you will have a total of 2 hours, and that you have to finish it all in one sitting. You can't start it, stop, and then start another time. Once you stop, it automatically submitted. I will be available on Tuesday by email if you have any problems with your with working your exam, if your internet shuts down or you get cut off for some reason in the middle, email me. I will be able to reset you the exam for you. The problem with this final, just like it was with the midterm, is I can't just reset part of it. It's not like Delta Math. I can reset the whole test. But let's say there are a total of 30 questions. And let's say you worked for half an hour and you did 10 questions and then the thing shut down on you. Obviously, you don't want to end up having a mark that's just 10 out of 30. So you will get in touch with me. You will email me. I'm not going to say I'm looking at my email every single instant, but every 10 or 15 minutes, I will look at my emails to see if there's any problems. If it is, I will reset it. But again, once it's reset, you're going to have to start from the beginning. It's not as if you can start in the middle. Unfortunately, I don't have that kind of control. Okay, so let's look at these two problems and see if we can do them. I see Kava sent us answers to both of them. So let's see if she got them right. This first question is what's called a compound or a double inequality. What it says is -1 is less than or equal to x minus 5, which is less than 7. And what you want to do is concentrate on the middle and making sure what you get in the middle is just a plain x. So in order to get just x, I'm going to have to add 5 to the middle. Whatever I add to the middle, whatever I do in the middle, I do at either end, on the right side and on the left side. And when we add -1 plus 5, we get 4. And this is less than or equal to, the 5 cancels out, so I'm just left with the x. And 7 plus 5 is 12. Now this is my answer. Once I have x all by itself, this is my answer written as an inequality. There are 3 ways to write the answer. One answer is as an inequality. Another way to write it is by graphing it on the number line. Here's my 0. So here, let's say this is 2, 4. Let this be 4, 6, 8, 10. Here's 12. This says 4 is less than or equal to x. So at the 4, we're going to have a filled in circle. Here's my 12. I have to have an open circle. And I fill in everything in between. That would be the graph, the number line graph of the solution. The interval notation we do by starting with a number that's on the left, which is the 4. That's our first number. Our second number is the number that's on the right. And since the 4 is filled in, it's what we call closed. We make a bracket at the 4. The 12 is an open circle, so we make a parentheses. And this would be your answer in interval notation. Be very careful when you're picking the answers. It's so easy to pick the wrong answer because you had to concentrate on whether you have a bracket or a parentheses. Don't forget, when it's filled in, you have a bracket. When it's open, you have a parentheses. Okay, so that was question number 1. Question number 2. Okay. You see some people have gotten some answers for question number 2 as well. Let's see if we can do question number 2. The question number 2 is a absolute value equation. To solve an absolute value equation, the first thing is you have to get the absolute value all by itself. So this +2 that's on the outside has to be brought to the other side. So I'm going to subtract 2 from both sides. This will give me the absolute value of 1/4 x minus 5 equals 6 minus 2, which is 4. Before I do anything else, I look at this number over here. This number has to be a positive number. If there's a negative over here, I can stop right there. There's no solution. It's impossible for an absolute value to be negative. The whole point of absolute value is that it's positive. But this is positive, so we break it up into 2 equations. The first equation is 1/4 x minus 5 equals 4. The second equation, and don't forget, you have to have a second equation, is 1/4 x minus 5 equals -4. And you have to solve both of these equations. Solving this one, I'm going to add 5 to both sides. So that'll give me 1/4 x equals 4 plus 5, which is 9. I see my. And to get rid of the 1/4, I'm going to multiply both sides by 4/1 by the reciprocal. So 4/1 times 1/4 will give me just 1x or x. And 4/1 times 9 will give me 36. So that's one answer. Over here again, I'll add 5 to both sides. So this will give me 1/4 x equals, this cancels, equals -4 plus 5, which is 1. And again, I'll multiply by 4. So 4/1, the 4/1 times 1/4 will just give me the x. And the 4/1 times 1 will give me 4. So my 2 answers turn out to be 4 and 36. And you don't have to put them in those braces, but they can be. So that's the questions from the first chapter. I'll give you 2 more questions. I'm going to put 2 more questions on the board. And while you're doing that, I will take attendance. What if I ask you this question? I have a line that goes through the point 0, -5. and it's perpendicular to negative 3y minus 2x equals 5. Okay, I want you to write the equation of that line that goes through the point 0, negative 5, and is perpendicular to this line. Let's do that, the one question. And here, let's do this question. Question number 2. Suppose I tell you that f of x is equal to x squared minus 5. Can you find f of 2x plus 1? Okay, I'm going to give you time to do these two while I take attendance. Okay, Maury Labre. Are you here? Thought I saw your name. Yeah, I do see you're here. Okay. Chelsea. Chelsea here. Ariana.
Hi, I'm here.
Hi, how are you? Adina?
I'm here.
Yeah, I know I can count on you. Lachey?
I'm here.
Hi.
Hey.
Kava, I know you're here. Terrence Cruz. Karide. Yeah, I see you're here, Karide. Kizia.
Here.
Hi.
Hi.
Faith. Ethan.
Here.
Hi. Isabella? I see you're here. Serenity?
Here.
Reggie? Saw you before. Zamia? Brandon? Yeah, I have you, Maury. I saw that you were here before. Brandon here? Michaela?
I'm here.
Hi. Seraphine? Marissa? I see you're here, Marissa. Renee?
Here.
Hi. Sky? I saw you were here, Karita. Okay. Jaden? Kennedy?
Kennedy got disconnected, so she's coming back.
Oh, okay. I'll mark her present. Thank you for letting me know.
Hi, you're welcome.
Felicia?
I'm here.
Yeah, I see you. They're here. Natalia?
Here.
Hi. Michael? I see you're here, Michael. Cassidy? Hi, Cassidy. Megan? Yeah, I see you're here. Kayla Watson? Lauren?
Here.
Hi, Lauren.
Hi.
And Kayla Zachary? I see you're here.
Here.
Thank you. Okay. Let me just check this one, 2, 3. Okay. Okay, and I see a couple of people have come up with answers. So let's see if we can do this, these two problems. Let's remind ourselves that saying that lines are either parallel or perpendicular gives us information about their slopes. Parallel lines have the same slope. Lines that are perpendicular have what we call opposite reciprocal slopes. In other words, they have slopes where you switch the fraction to the reciprocal, you flip it over, and you change its sign. That's why it's called opposite or negative reciprocal slopes. So when I look at this equation, the first thing I want to do is try and figure out the slope of my original line. And I do that by putting it in what we call the y equals mx plus b form. We get the x to the other side. So that I get negative 3y equals 2x plus 5. And then, of course, I divide by negative 3. So my original line, the line that I started out with is y in the y equals mx plus b form is y equals negative 2/3 x minus 5/3. And the slope here then is negative 2/3. My original line has a slope of negative 2/3. So when I'm going to here, let's go over here. So when I'm going to my new line, the slope is going to have to be the opposite reciprocal. I'm going to flip this over and change its sign, so it's going to be positive 3/2. So here's my equation. Y equals 3/2 x plus b. We still have to figure out the b. The b is the y-intercept. Now I could just take the point and replace the values of x with 0 and the y with negative 5. If I do that, I'll get negative 5 equals 3/2 times 0 plus b. And anything times 0 is 0, so it means that the b has to be equal to negative 5, which I would have realized also. I didn't even have to do that, because when the point is 0, negative 5, 0, negative 5 is on the y-axis. It means the axis, you're not going left to right, so it's on the y-axis. The y-intercept is negative 5, so that would mean that your b is equal to negative 5. So your equation then becomes y equals 3/2 x minus 5 as the line, the perpendicular line going through that point. So you have to be able to write the equation of the line. You put it in the y equals mx plus b form. But remember, when it says something like parallel or perpendicular, it's telling you about the slope. Looking at the second equation, I was told, the second question, I was told that f of x is equal to x squared minus 5. So I want to find out what f of 2x plus 1 is. And what that tells me to do whenever I'm doing f of x, whatever is in this parentheses, I replace the x with it. So I'm going to take out this x from over here, and I'm going to replace it with the 2x plus 1. So I'm going to have to do 2x plus 1 squared minus 5. And usually I don't leave it in this form. I want to expand it, combine the like terms. So the first thing I have to do is 2x plus 1 squared, which means I'm multiplying 2x plus 1 times 2x plus 1. So using FOIL, I have to use FOIL because this is a binomial. 2x times 2x is 4x squared. Outer is 2x. Inner is also 2x. And last is 1 times 1, which is 1. So this becomes 4x squared. And I have this, let me just attach this negative 5. So this will give me 4x squared plus 4x. And 1 minus 5 is negative 4. And this would be the answer in expanded version. Okay. Sky, I see that you're here. Okay. Okay, so you have to know how to do this type of figuring out how to find f of something. Sometimes they just give you f of a number. They tell you find f of 5, that just means replace x with 5. But if they say find f of x plus 2, it means replace the x with x plus 2. Your final answer shouldn't have any f's in it. Okay, so now I'm going to give you 2 more problems to try. And again, today is review day. We're just doing different types of problems that you may encounter on your final exam. Different types. So next 2 questions I want to do have to do with systems of equations. First of all, let's look at an example that is a question of systems of equations. And then we'll do one that is a word problem, just as a reminder. So first of all, just solve the system of equations. Suppose we have x minus 3y equals 15. And 7x minus 2y equals 10. So that's the first one. The second one is going to be a word problem. We have tickets to a school play, and they cost $5 for student tickets. And they cost $8 each for adult tickets. And we had a total number of tickets that were sold were 360 tickets sold. And the total amount of money that they made from selling all these tickets was $2,640. And we want to know how many of each type of ticket was sold. Okay, so let's see if you can do these 2 problems. I'll give you some time to try them. Okay. I see there's the answer to question number 1. Let's see if you can get answer number 2. We'll give you a couple more minutes. Let's see. Okay, let's see if we can do these 2 problems now. So this system of equations is set up in what we call standard form, where we have the x's, the y's, the equals, and the numbers all lined up. And we usually use what's called the elimination method or addition method to solve it. So for this one, let's try and eliminate the y's. And if you remember, the way we do the elimination method is we multiply each equation by the opposite coefficient. First, we just look at the numbers. The top equation will multiply by the 2 because it's the y's we're trying to get rid of. And the bottom equation will multiply with the 3. Now let's talk about whether we should use both positive numbers or if one should be positive and one should be negative. And since both of these are the same signs, and in order to eliminate it, we need one to be positive and one to be negative, I'm going to use a negative with one of them. It doesn't matter which one. I put it with the top one. So that my top equation, if I multiply by -2, becomes -2x plus 3y equals -30. And the bottom equation, I'm multiplying by +3, gives me positive 21x minus 6y equals 30. And now I just add these 2 equations down. The -2x plus the 21x gives me 19x. The positive 6y and the negative 6y canceled. Well, that was the whole point. I said, let's get rid of the y's. So that's what we're doing. The y's have been eliminated. And the -30 plus 30, that gives us 0. So when I divide both sides by 19, my answer comes out to be 0. 0 divided by anything is 0. So my x turned out to be equal to 0. If I want to figure out what the y is, I go to either one of the original equations and replace the x with 0. Let's say take the first equation. So this will be 0 minus 3y equals 15. And of course, 0 minus 3y is just -3y. So -3y equals 15. If I divide by -3, will give me y equal to -5. So my solution is x is 0, y is -5. I think that's the answer that some of the people came up with. What about this second example? Well, we said that they were the student tickets were $5 each and the adult tickets were $8 each. Let us call the number of student tickets that were sold X. Now, I'm saying it to you, but if you write it down, you really have to be specific as to what your X. X doesn't just mean it's student tickets, it's how many student tickets were sold. And the Y is gonna represent the number of adult tickets that were sold. So my first equation becomes X plus Y equals 360. We were told that a total of 360 tickets were sold. So the students together with the adult tickets, the X plus Y together gives us 360. In terms of the money, we have to now include the price of the tickets. The amount of money they made from the student tickets was 5X. Each ticket cost $5. 5 times the total number of tickets will give you the 5X, will give the amount made from the student tickets. That together with the 8Y, that's how much was made from the adult tickets, will give you the total 2640. So this is you have to write the system of equations. And then, of course, you have to solve it. So let's see if we can solve this. Again, we want to eliminate one of the unknowns, because again, we have this X, Y equals. I'm going to eliminate the X's this time. I'll multiply this by 5 and this by 1 if I'm multiplying. And again, they're both positive, so I'm going to have to use a negative with one of them. I'm using a negative with the first one. So the first equation will become negative 5X minus 5Y equals negative 5 times 3,600, which is negative 1,800. And the bottom equation, if I'm multiplying it by 1, just stays the same. 5X plus 8Y equals 2640. Okay, now adding these two equations, negative 5X plus 5X cancels. Negative 5Y plus 8Y gives me positive 3Y. Okay, now, where's my calculator? Is well, use my calculator. Negative 1,800 plus 2640 gives me $840. And now I have to divide by 3 to get the Y alone. And it gives me that the Y is 280. Notice how important it is to be able to have your calculator handy and know how to use it. So we know that 280 adult tickets were sold. To figure out how many student tickets were sold, let's go to our original equation, X plus Y equals 360. X plus 280 equals 360. And if I subtract the 280 from both sides, that gives me X equals 80. So 80 student tickets were sold. And that would be using systems of equations. This is just a system of equations. This is a word problem that uses systems of equations to solve it. Okay, I'm going to put some more problems. Let's go on to the next section. The next section had to do with polynomials. And the most important thing that we learned to do in polynomials had to do with factoring. So let's see if we can look at some factoring examples. So first, a factor, and both I want these factored completely. 100 x squared minus 36y squared. See if you can completely factor that. And here's number 2. See if you can factor this. 2a to the third plus 4a squared plus 9a plus 18. See if you can factor this. This you're going to have to use the grouping method because it's 4 terms. Okay. Okay, let's start with doing this first one. Whenever we go to factor, don't forget the first thing you want to do is look, is there a common factor? Is there something that goes into every single term? And if you notice, 4 goes into 100 and it also goes into 36. So I'm going to put the 4 on the outside, and that'll give me 25x squared minus 9y squared. Always look to, especially when you're factoring completely, always look to see if you have a common factor. The next thing you want to do is you want to see if you can factor further what's left in the parentheses. Now, this is what's called the difference of squares. This is a perfect square and this is a perfect square, and there's a minus in between them. So you leave this 4 on the outside and you break this up into what we call conjugate binomials. It's 5x plus 3y and 5x minus 3y. It doesn't matter if you put the one with the plus first or the one with the minus first, but one of them will have a plus in it, one will have a minus, but the two binomials will be identical. And that's called that's how you would factor it. Don't first break it up into two binomials. First, look for your common factor. Okay, in the second one, this is 4 terms. When we have 4 terms, well, again, we look for something that goes into all 4 terms, but I don't see anything that goes into all 4 of them. So then I want to do what's called grouping. I'm going to look for something that goes into the first 2 terms. 2a cubed and 4a squared has a common factor of 2a squared. 2a squared into 2a cubed gives me a. 2a squared into 4a squared gives me just plain 2. The a's are canceled out. In my second group, I have a common factor of 9. So I have 9 times a plus 2. And after I've done that, I see that the a plus 2 is the common factor of both. So I put that a plus 2 in the front. And in my second parentheses, I put whatever I see on the outside, which is the 2a squared plus 9. I don't see any other way of factoring this thing, this 2a squared plus 9. So this is the final answer, the final complete factorization. Okay, so now let's go on to see if we can do an example where we are dividing polynomials. Here's an example. Suppose I want to divide 6x squared minus 26x plus 25 by the binomial 2x minus 4. I want to divide the trinomial by the binomial. See if you remember how to do that. I'm only putting one on because it takes up a lot of room. Give you a few minutes to try that. Okay, I see we have an answer, so it means that we can start doing it together. Let's see if that's the correct answer. Remember, when I'm doing division of polynomials, I have to do it as a long division. I'm gonna put the 2x minus 4 on the outside. And inside my division sign, I'm gonna put the 6x squared minus 26x plus 25. Don't forget, these terms that you're dividing into have to be in what we call descending order. The highest power, then the next highest power, then the next highest power. And if any term is missing, let's say it starts at x cubed, and then the next thing you see is an x, and you're missing an x squared term, you have to put in a 0 for that missing term. Then what you do, after you have it all set up, you take your first term of your divisor, which is 2x, and divide it into the first term of your dividend of what you're dividing into. So 2x into 3x into 6x squares gives me 3x. I take what I just put on top, the 3x, and I multiply both terms by it. 3x times 2x is 6x squared. And 3x times negative 4 is negative 12x. And the next thing I have to do is I've got to subtract. And I subtract by changing the sign. So this is going to become a negative, and this is going to become a positive. And the 6x squared minus the 6x squared cancel. And the negative 26 plus the 12x give me a total of negative 14x. And I bring down my next term, which is 25. And now I divide the 2x into the negative 14x. So that will give me negative 7. Remember, the x's cancels. And now I multiply. Negative 7 times 2x is negative 14x. Negative 7 times negative 4 is positive 28. And again, I have to subtract. So this is going to become a plus, and this is going to become a minus. And now I have negative 14x plus 14x, which cancels, and 25 minus 28, which is negative 3. There are no x's left. There's nothing more to bring down. This negative 3 is our remainder. Sometimes they want it separate. What's the quotient? The quotient is 3x minus 7. The remainder is negative 3. But very often what we do is we take the remainder and put it over the divisor. So the final answer would be 3x minus 7 minus 3 over 2x minus 4. The final remainder you put over the divisor. Let's see. Okay. Okay, Terrence, I see your message. Okay. I will mark you present. Okay, let's do a couple more. Obviously the next topic would be the fractions or rational expressions. And the topic after that was radicals and i's and quadratic equations. The last three topics we reviewed last time. Remember, we reviewed logs, trigonometry, and part of the conic sections. That's also, don't forget, you can always review on your, using those study guide sheets that I gave you. But let's just do one example with radicals and one example with solving a quadratic equation. Again, we won't have covered all the different types of problems, but we'll have gone through a lot of them. So let's see if you remember how to handle a question like this. Suppose I told you to simplify this. 8 plus I over -4 minus 3I. I'm going to give you a couple minutes to try that example. Okay, see, Reggie came up with an answer, so I think we can start working on this together. Whenever we have something that says simplify, and you either have an I in the denominator or a radical in the denominator, what you want to do is what's called rationalize the denominator. You want to have the denominator being a regular number. And since the denominator is -4 minus 3i, it's a binomial. In order to rationalize it, we multiply by what's called the conjugate. And the conjugate of the denominator is -4 plus 3i. If this would be a radical, we would do the same thing. Of course, whatever we do to the denominator, we do the same exact thing to the numerator. Now, when we multiply the denominators together, I always like to do that first. Remember, when you're multiplying conjugates, you do not have to do the whole FOIL. You could just do first and last. So -4 times -4 will give you +16. And -3i times +3i will give you -9i squared. And remembering that the I squared, whenever we come across it, is equal to -1, this becomes 16 plus 9. -1 times -9 is plus 9, which is 25. So my denominator is going to turn out to be equal to 25. And that's what we were looking for. We were looking for a rational denominator, means just a regular number, no i's, no radicals, nothing. Of course, we now have to do the numerator. So we have to do FOIL on the numerator as well. And here we actually have to do the whole FOIL because they are not conjugates, they're just two binomials. So first, a times -4 is -32. Outer is a times 3i, which is 24i. Inner is positive I times -4, which is -4i. And last is I times 3i, which is 3i squared. Now again, this I squared is -1. So this becomes -3. So we have a -32 and a -3, which gives me -35. And the 24i minus 4i is 20i. Now, usually when we're given these, they want us to put it in what's called a plus bi form, which means to separate it. Put the -35 over the 25 plus the 20i over the 25. And if we reduce these fractions if we can, I can divide the top bound by 5, so this becomes -7 over 5. And here I can divide by 5 and I get plus 4i over 5. And that would be your answer in a plus bi form. Okay. Let's do just one more problem. Let's do a quadratic equation problem. Very important for you to be able to solve a quadratic equation. So what if I gave you this equation? X squared equals -5 minus 2x. See if you could solve that quadratic equation. Okay, let's see. Yeah, I understand, Ariana, but let's do it together. I see we're getting some, see if we get some answers. Obviously, it's a quadratic equation because of that x squared. So we want to get it equal to 0. So I'm going to add 5 to both sides. And I'm going to add the 2x to the both sides. And I'm going to put the 2x in the front because I want the equation to be in descending order. X squared plus 2x plus 5 equals 0. Now, this is not factorable because there's no numbers that multiply to 5 that when I add them will give me 2. So I have to use either the quadratic formula or completing the square. I'm going to use the quadratic formula because we haven't used it in a while. Remember, the formula is -b plus or minus square root of b squared minus 4ac all over 2a, where my a is the number in front of the x squared, which is 1. The b happens to be 2. If this would have been a minus, I would have included that as part of my b. It happens to be positive. And my c is positive 5. So here are my 3 numbers. I'm sticking them in. -b, -2, plus or minus. And here you just have to be very careful with your numbers. It's going to be 2 squared minus 4 times 1 times 5. With my 4ac over 2a, so it's good times 2 times 1. And the first thing I'm going to do is I'm going to try and figure out what's inside this radical. So 2 squared is 4, and 4 times 1 times 5 is 20. So this is 4 minus 20, which gives me negative 16. So this becomes negative 2 plus or minus the square root of negative 16 over 2. Now we want to simplify if we can. And the first thing I remember is the square root of negative 16 really means the square root of 16 times the square root of negative 1, which is 4i. Don't forget, when you have a negative inside a radical, it translates to an I. So this becomes negative 2 plus or minus 4i over 2. And I can divide the 2 into both of these terms. So negative 2 divided by 2 is negative 1, plus or minus 2 into 4i is 2i. This would be your answer in simplest form. Don't forget to switch it to the I format. Reggie, that was good. Okay, Ariana, do you see that you should change that square root of negative 16 to 4i? Okay, I think we're going to stop right here. Just as a reminder, this is our last class. Our final exam is on Tuesday. You can take it between the hours of 9:30 and 3, which means you can start as early as 9:30. It will be available on Blackboard. Your final exam is on Blackboard. Once you start it, you have a total of 2 hours to complete. Do not think of going away in the middle. Your time, you can't stop and start. Once you start it, you must complete it in one sitting. You must start it latest by 1 o'clock in order to get your full 2 hours. When I say you must be completed by 3 o'clock, doesn't mean you can start at 5 to 3. Well, if you start at 5 to 3, you're going to have to finish the whole test in 5 minutes. It's going to close at 3. That's how it's going to be set up. Also, don't forget that if you haven't done all the work, you haven't taken all the tests or done all the homeworks, then you are going to not get the full 40 points that comes from the classroom work. Don't forget, 25% of your mark is your midterm. 35% of your mark is your final. The other 40% is the homeworks and the quizzes and tests. Now, I've given you a total of 19 homeworks on Delta Math. If you complete 16 or more, you get full credit. Otherwise, it's prorated. If you only did 8 homeworks, you'll only get half the credit. You won't get all the credit. So make sure you've done all the homeworks. Even if they're late, you'll still be getting full credit for the homeworks. They're available until a week from tomorrow. You have until a week, next Thursday, today's 9th, next Thursday. You have until the 17th to complete everything. After that, I'm going to be submitting my grades, and if I see missing work, I'm just going to say that's not going to give you credit for it. In addition to the homeworks, there were 3 tests on the math, and there were 2 tests on Blackboard. The one that was right before the midterm, and now the one that I posted that's before the final exam. That has to be finished by Monday. And of course, you have to do the final exam on Blackboard as well. If you are missing anything, or if you're missing a test, first of all, I'm going to go through everybody's charts and things, and I'm going to email you if I see you're missing work. If you need something to be opened up, you can email me and I will open it up for you so that you can, even if it's late, you can still do it. I will give you credit even if it's late. But you must let me know, especially if you didn't do a midterm or a final. If you're missing those type of things, Well, obviously the final, if you don't do the final, you don't get a mark, but if you're missing the midterm, that's 25% of your grade. You're missing a very large amount of work. Most people have been pretty consistent in doing their work. So again, check both Delta Math and Blackboard to make sure you've done everything that was expected of you. Again, if you run into problems when you're taking the exam, the final exam, and let's say it cuts out on you, your Wi-Fi cuts out on you, or your internet goes down, I will be available, checking the emails on a regular basis, every 10 or 15 minutes in that time frame. And if I see somebody has a problem, I can reset your test if you've been cut out of it. But when I reset it, it means you have to start from the beginning again. But I can do that for you, but you have to let me know. So remember, your final exam is not on Zoom. This is the last Zoom session we're having. Your final is on Blackboard on Tuesday. And good luck. Have a nice weekend. Rest up. Make sure you're ready for it. Do a bunch of practice problems. You can go back and look at all the different types of examples we've done. Again, a very good guide is this study guide that I posted on Blackboard. It has all the topics and examples of all the topics. The study guide from, I've shown it to you before, I don't even have the front page. Here, the study guide for Math 136. I posted it on Blackboard with the solutions to the to any of the examples they're on. Okay, have a nice weekend, everybody.
You too, Professor.
Bye-bye. It was a pleasure having you, Reggie. Bye-bye.